The idea is simple: have a piece of software that makes people smarter. That is basically all. This program helps people achieve their goals. At scale, even things like entire intermediary or consultative professions may become obsolete. Of all concepts of intermediary, arguably the biggest would be attorneys. The core of their job is to bridge between legalese and layman, among many other things. This is a good example of the level of capability this software will aspire to achieve. To clarify, this software is not a generative AI, or GAI. It could be called an unbounded expert system, though it may be more accurate to call it a guided inference engine. This is important to note, because it does not work at all like Chat GPT or other LLMs. In fact, unlike a lot of popularized AIs, you cannot use this technology at all without constant interaction. It is limited in its autonomy, and therefore keeps the human element strong. More on that later. Let's start with something very basic: making a cheese sandwich. Assuming the program doesn't already know what a cheese sandwich is, an interface appears to try to discover this. You'll be given prompts for the subject of your goal, beginning with a typical person, place, or thing category inquiry. From there, a battery of discovery questions will appear until the topic is guessed correctly. If this seems familiar, you're probably right: it's 20 questions. This prompting method is the main method the program uses to learn of new ideas from the user. However, sometimes it's faster to just tell the program what you have in mind. Let's assume the program has basic knowledge of things like bread or cheese or the concept of cooked food. Another interface would exist to enter manual information. Contains bread, multiple, 2. Contains cheese. Bread encloses cheese. Is cooked. Is food. Etc. The more knowledge it has, the less questions or inputs are needed. The program will also need to know the circumstances of your sandwich to understand how to make a goal out of it. For example, you can't simply make a sandwich out of thin air, nor teleport yourself or the sandwich from the kitchen where it's made. Time, distance, and accessibility parameters need to be questioned, usually. Generated plans are built to handle contingencies. They can also be viewed as trees or graphs, as needed. With plan in hand, the program prompts the user to begin enacting each step as it becomes available. Users indicate when they've made progress, and the plan is implemented in the real world. But wait! Suddenly, you drop your cooking spatula on the ground. This was not part of the plan. Quick, you must tell the program of this new information. It should tell you that cooking utensils must be clean, and things being on the floor generally become unclean, unfit for eating. It also tells you the scant few seconds to clean the spatula is too long, and your cheese will burn if you try it. What do you do now? Maybe there's a compromise solution. Let's try being more specific about utensil cleanliness. The floor is only unclean to parts of things that directly contact it. Otherwise, any person walking about would always be wholly unclean. The spatula landed backside down, so only that part is in contact with the floor. Though it's not certain, the face-up side of the spatula may remain clean. This also happens to be the side that is most directly used for simple cooking, in this case. Now a decision is present: a risk, but not a certainty, of floor cooties on your food, or a slightly crispy sandwich. The choice is yours. This should give you an idea of how the software is used. As we just saw, this program explores the logical possibilities associated with any given problem-solving scenario. This is made possible by several mechanisms. First, there's the human element. Though the software may, eventually, grow to be able to reason upon most problems on its own, also known as an AGI, it is not built like a GAI, and will always keep humans in the loop. Deciding the fate of a floor-bound spatula is a somewhat guessable problem for a human. However, humans don't always stop to ask themselves what sort of options they have, particularly in emergent situations, such as with our fallen spatula. The software knows how to prompt the user to do this. The program will know that overgeneralized details exist with almost all data. Not all available information is relevant for meeting goals, so most of it gets abbreviated. How often do you even drop your spatula, anyway? Since most information in this system is like that, the program explores these vagaries smartly to discover the right questions at the right time. The human user can then figure out solutions on their own. With this, problems of almost any complexity can feasibly be tackled. Maybe even entire professions. The other element of this program's functionality are its set of smart algorithms, which implement something called an inference engine. These infer new information from existing information. For example, even though a human could be nudged into guessing at the nature of spatula cleanliness, the computer can also understand that a spatula is a flat, solid, dense object with two sides. It must obey gravity, and may rest upon only one side at a time. An algorithm can infer that a side of the spatula hasn't touched the ground, and thus cannot have any floor cooties. Not all problems are well defined enough for software to easily infer solutions. This is why a truly generalized AI hasn't been made yet. However, all such problems can eventually be solved by having enough of the needed information. The more people use this software, the smarter it gets. In the meantime, the software can at least ask users the right questions at the right times. People may often guess at solutions better than computers can anyway. We need this sort of program to exist. It is a doable endeavor, maybe even by nothing more than a given motivated garage dwelling code monkey. Maybe even you. We need to make as many prototypes, iterations, forks, supporting technologies, user interface experiments, and constraint-solving algorithms for this as we possibly can. The more the merrier. Imagine the long game. Everyone and their grandmother is using a technology like this, more so than any now popular AI, and thus literally making humanity smarter. Imagine a world, for example, that no longer needs things like lawyers. Contact your local geeks, or even pick up a compiler yourself, and start chipping away.